Welcome all to today's class. We have been discussing Standard 9, Chapter 1. Chapter name is Sets. So today we are continuing the chapter Sets. So we have been discussing what is sets, subsets, Venn diagram, two types of set, builder and roster form of writing is sets, equal sets and all. So today we are going to continue that chapter. So we have seen the two methods of writing a set, that the set builder form and the roster form. Also we have seen different types of sets, singleton set, null sets, finite sets that have finite number of elements, infinite sets, it have infinite number of elements, and equal sets. We can say equal sets when it have exactly same, two sets have exactly same elements, we can say the two sets are equal. Also we have seen the Venn diagram to represent the set. Seen the subsets, that is if A, B is subset of A, then its Venn diagram will be like this, that is B is contained inside A. Now we are going to discuss today's topic, that is universal set. So what is universal set? It is a bigger set which will accommodate all the given sets under the consideration, which in general known as universal sets. So universal set is a bigger set which accommodate all the given sets under some given condition, and it is represented by the letter U, so that the sets under consideration are the subsets of the universal set. So here an example is given. I am going to read it. A cricket team of 15 students is to be selected from a school. Here all the students from school who play cricket is a universal set. So a cricket team of 15 students is to be selected from all the students who play cricket in that school. So the set that all the students who play cricket in that school is called the universal set, and a team of 15 cricket players which is to be selected will be a subset of that universal set. So you can see generally universal set is denoted by the letter U. So Venn diagram is given here. So all the students in the school who play cricket are the universal set, and a team of 15 students which is to be selected is contained a subset of that set U. So you know what is universal set. It is a bigger set which accommodate all the subsets under a given condition. So now we are going to know what is complement of a set. Suppose U is a universal set, B is subset of U, then set of all elements in U which are not in B is called complement of B. So what is a complement of set? We can directly go to the example. So here U is given, so I have written it here. U is a set of numbers, natural numbers between 1 to 10, that is 1, 2, 3 up to 1, 2, 3, 4, 5, 6 up to 10, and A is a set of even numbers in that 2, 4, 6, 8 and 10. So now we have to find a complement, that complement of the set A. So we will represent it as this way, A dash, a complement represented. So a complement will be the elements in the set U which are not in A. The elements must not be in A, but it should be in U. So the first element in U is 1, and 1 is not in A, so it will be contained in A complement. Next element is 2 is contained in A, so it will not be in A complement. 3 is not in A, so it will be in its complement. Again 4 is in A, so it will not be in complement. 5 is not in A, so it will be in A complement. 6 is in A, 7 is not in A, so it will be in A complement. 8 is in A, 9 not in A, so 9 will be A complement, and 10 is in A. So this set is called A complement of the set A. Complement of the set A is this set of elements which are in U but not in A. So you can see the Venn diagram of A complement. Venn diagram of A complement, that those elements which are in U but not in A. So elements outside the set A will be the A complement inside U. So Venn diagram of this one is here shown. The set of A complement will be all the odd numbers 1, 5, 7, 9. You can see 1, 3, 5, 7, 9. So here is a problem. U is given, P is given. U is a set of elements 1, 2, 3, 7, 8, 9, 10, 11 and 12. 1, P is 1, 3, 7, 10. Show the sets U, P and P complement by Venn diagram. So we have to represent U, P and P complement by Venn diagram. For that, first we should find P complement. U and P are given, universal set, and a set P is given. So we can find its complement of this set P. So P complement will be the set of elements which are in U but not here. So those elements which are not here but in U, that will be the set of P complement. So 1 is here, 2 is not here, so it will be here. 3 is here, 7 is here, 8 is not here, so it will be in P complement. 9 not in P, so it will be in P complement. 10 is here, 11 not in P, so it will be in P complement also. 12 also not in P. So this will be the set of P's complement will be set of 2, 8, 9, 11 and 12. Now we have to represent the set U, P and P complement in a Venn diagram. So how it will be? So this is the set universal set U. Since P is subset of U, I am marking P inside U. So what are the elements in P? That is, P is this 1, 3, 7 and 10. So and now what are the elements that are in P complement? P complement or rest of the elements in U will be 2, 8, 9, 11 and 12. So this is a set U and P is subset of U, so I have marked P inside U, that is set P is 1, 3, 7, 10, it is inside U and P complement is here. P complements are those elements in U and not in P I have marked outside. 2, 8, that is P complement. 2, 8, 9, 11, 12. So that are inside U but outside P, not contained in P, contained in U. So P complement and P. So problem 3 is solved here. Now let's go to problem 4. Problem 4 is we have to A is given, write any 3 subsets of A. We have to write any 3 subsets of A. So I am writing the subset like this. This is subset. I am naming B another subset of A. 3, 2, 7. This is another subset and another subset of A will be 2, 7. So we can write in any number. Subset means any set that is contained in A. So any number of elements can be included in subset. Lesser than, so we can add here 4 elements are there. So we can include in subset any lesser number than 4, that is 3 elements or 2 elements. So this problem I have written 3 subsets of A. So now we are going to operation on sets. So the first operation on sets is intersection of 2 sets. So suppose A and B are 2 sets, then what is the intersection of A and B? Intersection of A and B is represented as this. So intersection of A and B is the set of all common elements of A and B, denoted by A intersection B, read as A intersection B. So A intersection B is the set of elements X such that X will be an element of A and also X will be element of B. So the set of common elements in A and B is read as intersection of intersection of A and B or A intersection B. So let's see an example of this. So 2 sets are given, A and B. So I have written it here, A 1, 3, 5, 7, B 2, 3, 6, 8. We have to find A intersection B and also write it, draw it in Venn diagram. So let's find what is A intersection B first. A intersection B means elements common in both A and B. So you can say, just check it. 1, 3, 1 is not here. 3 is common in A. 3 is also in here, A and also in B. So 3 will be in A intersection B. 5 is not here, 7 is also not here, so rest of the elements will not be here. So A intersection will be the set 3. It will be having only one element, so that is 3. So now let represent it using Venn diagram. This is the set A. The elements of set A are 1, 3, 5, 7. 1, 3, 5, 7. Now let us draw B. So this is the set B. So elements of set B are 2, 3 is already inside B, 6 and 8. So 2, 3, 6 and 8. So A intersection B will be like this. So intersection part is this part. So what is the element in this part? 3 is the only element. Like see in this image, 3 is the only element inside A intersection B. Rest 1, 5, 7 is not inside B, so it is drawn outside this B. So only element contained in this A and B is 3. So now we are going to the next topic is disjoint sets. Disjoint sets means that two sets which doesn't have any element in common. So we have seen in intersection, what is the intersection of two sets? They have any element in common. See in this A intersection B, they have 3 in common. But in disjoint sets, they doesn't have any elements in common. You can see a set A of 1, 3, 5, 9 and set B of 2, 4 and 8. They don't have any elements in common. Different numbers are inside these two sets. So this can be A and B are examples of disjoint sets. This is the Venn diagram of disjoint set. So the next topic is union of sets. What is the union of sets? If A and B are two sets, then all the set of all elements of set A and B is called a union of the two sets A and B, written as A union AUB. That is A union B, and it is a set of elements X such that X will be either element of A or X will be element of B. So A union B is the set of all elements of set A and B. So here an example of A, -1, -3, -5, -0. These are the set A, and set B is 0, 3, 5, 0, 3, 5. And now we write what is A union B. A union B will be the set of elements of set A and B together. That is A -1, -3, -5, 0. And what are the set of elements B? 3, 5, 0 is already written. So this is A and B are this, and A union B will be -1, the set of elements in both A and B. So you have seen what is A union B, and also we have seen what is A intersection B. That is elements common in A and B, and A union B is all the elements in A and B. Here a Venn diagram is given. We have to observe the Venn diagram and write the following using listing method. That is, we have to write the sets in listing method. So we have to observe this Venn diagram and write this. So first question is we have to write U. U will be the set of all the elements inside this. That is elements in A, B intersection and all the elements outside this A and B. So the first question is U. So this is set U, that is all the elements inside A, inside B and all the elements inside A and B and in intersection. So all the elements inside this is the set U. So now we have to write what is A. A will be the set of all elements inside this circle A. That is the elements. You can see what are the elements inside A. 6, 4, 2, 8 and 10. So this is a set A. Now we have to find what is B. So B will be equal to the set of all elements inside this circle B. B will be 1, 7, 3, 5, 8, 10. You can see in this image 8 and 10 is both inside A and also inside B, so it will be in both A and B. So what is next? We have to find AU, AB I have found, and AUB is the next one. So I am finding AUB. AUB, we have seen what is AUB, elements in both A and B. So what are the elements in A and B? So it will be a set of both the elements in A and B. So it will be 6, 4, 2, 8, 10, 1, 7, 3, 5 and 10. 8 and 10 is already written, so I am not repeating it. We have to write only once in a set. So this is the set AUB. Next is A intersection B, that is elements that are inside both A and B. A intersection B is very clear from the image, that is 8 and 10. Set of all elements 8 and 10, clear from the Venn diagram. What is next? Next is A complement, that is A complement. So elements in A, elements in U that are not in A. So elements will be here and not in this. So you can see A complement will be the elements inside U and outside A. So it will be set all the elements outside this circle of A. That will be, I am writing directly 1, 3, you can see from the image, 5, 7, 12, 11 and 9. So this will be the set A complement. So those elements inside the circle A are A complement. So it will be 1, 3, 5, 7, 12, 11 and 9. So what is the next? So we have found A complement. So now we have to find B complement, that is all the elements outside this circle of B. That's so it will be 2, 6, 4, 12, 11 and 9. So this will be the set B complement, all the elements inside this circle of B. That is so all the elements inside the U and outside B will be B complement. Next is A union B whole complement. So A union B we have already found, that is all the elements inside A and B, and A union B is all the element inside A union B. We have to find the complement of A union B, that is AUB whole complement. AUB complement of this set, that will be the set of all the elements outside AUB, outside A and B. So that will be set of 12, 11 and 9. 12, 11 and 9. So at last we have to find A intersection B whole complement. So what is A intersection B? A intersection B is the set 8, 10. From the Venn diagram it is clear, 8, 10, A intersection B is. So we have to find the complement of this set, that is A intersection B whole complement. So it will be the set of elements outside this 8 and 10. All the elements outside this part 8 and 10, all the elements inside U that are not in A intersection B. A intersection B part is this. So that are the set of 6, 2, 4 and rest 1, 3, 7, 5 and 12, 11 and 9. So this will be A intersection B whole complement. So I have solved this example too. So next is number of elements in a set. Number of elements is just how many number of elements, count of elements in a set. So here an example B is given. So I am going to find n of B and number of elements in the set B, written as n of B. So we have to count the number of elements in this set. 1, 2, 3, 4, 5, 6. So the number of elements n of B will be 6. So next we are going to n of A, that is how many elements are in the set A. So represented as n of A. So counting the elements 1, 2, 3, 4, 5. So 5 elements in A. So n of A is equal to 5. Again another set is given, that is A union B. We have to also find n of A union B, that is the number of set in A union B. We can count 1, 2, 3, 4, 5, 6, 7, 8, 9. So n of U is 9 and an A intersection B. So n of A intersection B, it have two elements, that is 1, 2. So n of A intersection B will be 2. So we have find n of B, n of A union B, n of A intersection B. We are going to substitute. Here an equation is given, so we have to solve this equation. We have to prove this equation is correct by solving this values, adding these values to the equation. So I can take this side of the equation, that is we have to substitute values in the place of n of A, n of B and minus n of A intersection B. So what is n of A? You can see n of A is 5 and n of B is 6. We are going to substitute this in this equation. So n of A is 5 and n of B, you can see n of B is 6. 5 plus 6 and minus n of A intersection B. So n of A intersection B is 2. So minus 2. So 5 plus 6 is 11 and 11 minus 2 is 9. So what is this? N of A union B, that is LHS is, we are finding value for n of A union B by solving values in this equation. So I got, according to this solving, I got n of A union B is 9. We have to check it with here. Yeah. So you can see n of A union B is 9. So we have solved that this equation is correct, that is LHS is equal to RHS. So this equation is solved. So we have to study this equation. What is the equation? N of A union B is equal to n of A plus n of B minus n of A intersection B. So this is the equation that we use when we solve word problem. So here is a word problem. So I am reading the question. In a class of 70 students, 45 students like to play cricket, 52 students like to play coco, and all the students like to play at least one of the two games. So there is a class which contains 70 students, and 45 of these 70 like to play cricket and 52 like to play coco, and all the students, that means the 70 students like some of the games to play, and we have to find how many students like to play cricket or coco and how many students like to play only cricket. So I am taking this class of 70 students, so our U will be 70. The total number of students in the class is 70, and let A be the students like to play cricket, and let B be the students like to play coco. So A be the number of students like to play cricket. So n of A will be is equal to 45 as given in the question. 45 students like to play cricket, and n of B will be, that is the number of students like to play coco, is 52, and n of A union B, that is the set of students who like to play cricket and coco, that will be 70. Since all of the students in this class at least like to play one of the two games, so n of A union B will be 70, that is 70 students like at least one of the two games. So n of A union B will be 70. So how many students like to play cricket or coco? That will be A union B, since A union B means either A or B, that is A says either they like to play cricket, or B means either they like to play coco. A union B will be 70. So what is the next? How many students like to play only cricket? For that, so the number of students who like to play cricket is 45. So among these 45, some will be liking both Coco and cricket. That means they will be liking also Coco also. So we have to find the first the number of students who like to play cricket alone. They only and also the number of that is our question, who like to play only cricket, and also for that we have to find the number of students who like to play both Coco and cricket, that is n of A intersection B. So first we have to find it. So we have seen the equation here. So by using this formula we are going to find it. So using this formula we are going to solve the equation. So here we have find what is n of A. So I am substituting it here. N of A is 45, n of B is 52. So 45 plus 52. Also we know what is n of A union B. N of A union B is 70. So I put 70 here. And we don't know what is n of A intersection B. So I am writing it as A intersection B. So taking the n of A to the LHS and everything to this side, this will be equal to 27. Solving this will be 27, that is n of A intersection B. That is A intersection B means students who like to play both cricket and Coco is 27. So we have to find what is the question, how many students like to play only cricket. So the number of students who like to play cricket is 45, that is n of A is 45. So we have to find from this 45 who like to play only cricket. So the for that we have to subtract from this who like to play both cricket and Coco, that is 45 minus n of A complement, that is 2. The students who like to play cricket only is equal to who like to play the cricket minus the students who like to play both cricket and Coco, that is 27. So 45 minus 27 is 18. So the students who like to play cricket only is 18, and also how many students like to play both cricket or Coco, that is 70. So we have solved this problem.